Hello guys, my name is Lucas and welcome to a new episode of our Cartoon Sea tutorial. In today's lesson we're going to learn how to make a boat or any other object that you would like to float on your sea to float. And how we're going to do this, you see the ocean has a lot of vertices, okay? Each point of intersection of these lines are vertices. And what we want to do is make our boat follow each, or not each, but the closest vertex to it. So we're going to first find the closest vertex to us, and then we're going to follow that Y position. First, I'm going to download a boat so that we can make it float on our sea. But you can actually download anything that you would like to make float on our sea. For example, you can make a chicken or a duck or a character or whatever you want, a box, a barrel. Anything will work. So we're just going to open that. Where is it? Simple wooden boat. There is a prefab folder. We have I think this will do for now, just this. And we're going to drag it into our sea. So there you go. And I'm going to make it a bit bigger. Maybe 1, like this. And there you go. The next thing is, if you realize the pivot point is not in the bottom of our boat, but rather in the middle. So if your game object doesn't have the pivot point down here, when we make it float, it's actually going to look like this, like it has water inside. So we want to make a parent for this game object. So we create empty. I'm just going to call it boat, and I'm going to drag the object there. And if you see now, we can actually you can take this out. We select the boat, we drag it until we see it's underneath our boat. And for that we can use the orthographic view. We can use the orthographic view to help us. So I just want to put it right under my boat. And now I'm going to parent the prefab to that game object. So we have something like that. Now we can go back to perspective view. And by the way, I made some changes in my water just because I wanted to adjust the filling of it. So you can set the stretching stiffness to 0.88. The world acceleration scale, I made it lower to 0.85. And I changed the wave controller as well, the height to 2.67 and the time to 2.35. So I get something like this. So right now you see our boat is just standing still there. It's not following the vertex. That is what we're going to do now. So we click on our boat and we're going to add a new script to it. I'm going to call it, I'm terrible with naming, I'm sorry, but let's call it, let's call it boat floater. Oh god, I'm very bad at this. Anyway, you choose the name that you want for your script. You can call it boat controller, please boat don't sink, or whatever you want. I'm just going to call it boat floater for now. Alright guys, so let's try to make this very quickly. I'm going to start by doing 3 variables. The first one is the plane of our sea, so I'm going to make a private transform Seaplane. This is going to store the transform of our sea that we're going to be floating in. The next variable is going to be not a pirate, but a private, and we need to get each vertex of this plane because we want to see which vertex are we closest to, and we're going to follow that Y position. So how we get the vertices of a mesh? We just need to use the mesh API. So private mesh, and we're going to call plane mesh. And finally we want a integer which is going to hold the index of the closest vertex to the boat. So closest vertex index. And we want to start it as a -1, okay? You will see why in a minute. Oh, and by the way, I forgot to mention, please make the boat a child of the sea. We're going to be needing that. And if you cannot do it for any reason in your game, we can make a work around that. But for now, it's easier if we just make the boat a child of the sea. Now we want to get the sea. I'm gonna get it by just tracking the names. So here in star, I'm going to use game object. No, sorry. First, Seaplane is going to be equals to game object dot find. We called it sea, and I'm going to get the transform. Then I'm going to set the mesh. So simply Seaplane. No, sorry. Plane mesh. Alright, that's correct. Is equals to Seaplane dot get component. I think we have to get it from the, because I see it has a skin mesh renderer. So skin mesh renderer, and we get the shared mesh. I think. I'm not sure if this is the one we want, but we will try and we'll see if it works. So seaplane, we set it here. The plane mesh, we get it from the seaplane, and that's enough for now. So next, we're going to make a new function called get closest vertex, and this is just a function to compare the closest vertex and the current vertex that we're looking for and see which one is closer to our boat, and we will just get that index and set it back here in the closest vertex index. So we're going to use a for loop, not a for each this time, but a for loop, because we need the index. So for int I equals 0, and while I is less than plane mesh dot vertices, so you see we have a vertices, and we even have a vertices count. Great. Vertex count, and not a comma but a semicolon. We will add 1 to our I. Here we want to make two local variables, within this scope. One is going to be the distance between the vertex that we're currently getting from this eye and the boat, and the other one is going to be the distance between the closest vertex and the boat. But before that, we want to set something here. So let me comment this, and if closest vertex index is equals to -1, this means we haven't set any closest vertex yet. We want to set this to, just set it to I. Closest vertex index equals to I. Or you can set it to 0 because we start at 0 anyways. So this is if we haven't assigned any closest vertex yet. We're going to do this. And then we're going to find the distance. So let's try here. Vector 3, distance is equals to vector 3 dot distance, and this returns a float to us, and we need to input 2 vector 3s. So the first vector 3 is the vertex. How do we get the vertex? Plane mesh dot vertices, and we use the index of our current for loop, the I. So here it's going to be 0, 1, 2, 3 all the way to 121. Plane mesh vertices, and we compare this with the second vector, which is this transform, the boat's transform dot position. Now we have the other distance that we need, which is closest distance, which is pretty much the same, but instead of using I as the index of the vertices, we use closest vertex index. Now the next thing we want to do is make an if statement again. So if the distance, okay, so that's the distance between the current mesh, the current vertex that we're looking at, is smaller than the closest distance, closest vertex index. Oh my god, closest vertex index equals I. That's it for our for loop. Now we want to, once that we quit the for loop, once that the for loop is done looping through each vertex, we want to set the position of our boat. So how do we do this? Just let's set the boat dot, let me try, transform dot position is equals to new vector 3, because we just want to change the y position, so we need to use a new vector 3, and I'm going to set it probably here, transform dot position dot x, so we want to keep the x. We want to get the plane mesh vertices, so we want to get the closest vertex, so plane mesh dot vertices closest vertex index dot y. And we also need a transform dot position dot set. That means we want to keep the set and the x, and we just want to change the y. So now if we, this should update the height of our boat and give the illusion that we're floating, following the closest vertex that we can find. So we will call this within our update. And if it's too heavy for your game, or maybe you're planning to make a mobile game or something like that, we could make an enumerator to call it not every frame, but maybe every 0.1 second. So it's going to stutter a little bit, but it's going to be very, very light on resources. And the other thing is that we will keep optimizing this script on next episodes. And so we will not need to check every vertex, but just the vertices around the closest vertex, which is going to improve our performance a lot too. So let's go to Unity and try this. I'm going to set this outside and just going to set everything to 0, 0, 0 and try it. And we're not moving. If you see, we have the boat, but it's staying at 0. Did we call this? Yeah. Well, we couldn't be actually programmers if we always get things on the first try. So maybe we need to make this like that. Maybe we really need to make it a child. And I see the boat is moving, but it doesn't feel like so this is the movement of the plane, but the boat feels like it's just standing there, moves so little. Let me stop and see what's the problem. Okay, so the problem I think is that we're getting the wrong component. So instead of getting the mesh, because the skin mesh renderer is not going to be actually moving, I realized that we can use cloth instead of the shared mesh, and cloth also has a property called vertices. So we will use the vertices of the cloth, which are the vertices that are actually moving. So we do that. I'm going to rename this from plain mesh, and we are going to use the rename function I mentioned at the beginning of this video. So press F2 and you see all the reference of this variable are selected, and we're going to call it plain cloth. And you see it's all renamed. And we still get the vertex count and the vertices because cloth also has this property. And remember to change here the class. So instead of mesh, it's a cloth. Okay. We don't have vertex count though, so we're going to use vertices dot length. All right. And let's see if this works. Recompile and play, and now it's moving much more, but it's weird because it's not actually following the vertex. And if I remember that because this scale is 10, I think we need to divide by 10 here. That's why it's moving more. And if we check it now, is it following the vertex correctly? Let's see the boat. And no, it's not, definitely not following that vertex. Let's make something here. Let's make a serialized field so we can actually see what is the closest vertex index and see if we are correctly. Yeah, the 60 should be the middle one, and if we move here, we change to 49. So we're actually getting the correct index, but the position is not being applied correctly. So let's try with local position instead of position. There and there. And let's try it now. And now it feels like it's actually following that, I think. Yeah, it's pretty much stick to it. So it goes up and the boat goes up. This is amazing. So now we have actually a boat floating on our sea, and if we see it through the game view, it's like that. And if we move the boat to other vertices, you see it's going to jump a little bit, but that's because it's actually updating the closest vertex index and is following a new vertex. So we don't like it to jump like that, so we're going to use a lerp or some other function to transit smoothly between different vertices. But for that, my friends, we need to wait for another episode. But right now you can use this. You can try to use lerp by yourself to see if you can make it smooth transition. As I mentioned, you can try to optimize your script by just checking the 8 closest vertices to the current closest vertex. You can write a function for that, and if you want me to do it for you guys and teach you how to do it, we can do that in the future as well. I'm very happy now because we made the boat actually float in our sea. You see it's following the vertex, whatever vertex we put it close to. We can put it over there, and it's going to follow that vertex, and it's really cute. And if you want to make your boat get deeper into the water, you just move the child of the boat lower so it gets through the water like this. But you will see some water getting into the boat because, you know, it's not actual fluids going around your boat, but rather just a very, very cheap trick. So maybe you can add a layer inside your boat to make it higher, so it looks like it's floating inside and you don't see the water through your model. And yeah, this works pretty well. We can make more changes, maybe 2 floating points, so it will float like the front of the boat is going to follow this vertex and the back of the boat is going to follow this vertex. But for now, please play around with this and keep learning, and I really hope you enjoyed the video. Please help me to give a like to this video if you enjoy it, and please subscribe to my YouTube channel if you haven't. I really appreciate all your comments, so thank you very much, and I will see you next time. Goodbye. Peace.